In this video 4.1, we are going to be looking at ratios and rates. By the end of the video and work time in class, you should be able to say, I can write ratios and unit rates, and also I can use rates to solve problems. The definition of a ratio is a comparison of two like values. For example, 36 seconds to 12 minutes. You're comparing the 36 seconds to the 12 minutes here, and they're like things. We also know that we can turn 12 minutes into seconds, so then we're really looking at 36 seconds to the 12 minutes, which is 12 times 60 gives you 720. So we're comparing 36 seconds to 720 seconds. We also know that we can reduce this. We can divide both 36 and 720 by 36. 36 divided by 36 is 1. 720 divided by 36 gives you 20. So we're looking at a ratio of 1 to 20. Now there are three ways that you can write a ratio. One is exactly how you see it right here already as a fraction. And we read this 1 to 20. And another way is using a colon, 1 to 20. You read it the same way, and a third way is using the word 2 in the middle, 1 to 20. Once again, you're comparing two like values. A rate now, the definition of a rate is a ratio that compares two different units. So we're looking at two different values here. Example, $4.50 for 30 minutes. We're working with dollars and minutes. They are different. A unit rate is when you have a rate for just one unit, and this means the bottom is a 1 when you're looking at unit rate. So if we look at $4.50 to 30 minutes, which is a rate, we want to make the bottom a 1. And so what we do, we know to turn 30 into 1 is we're going to divide by 30. 30 divided by 30 is 1. Whatever we do to our denominator, we're going to do to our numerator. We're going to divide by 30. So we do $4.50 divided by 30, and that would give you 15 cents. So 15 cents per minute is a unit rate. Whenever you see a 1 in the bottom of something, or you hear that word per, like miles per hour or $3 per pound, that word per, you're thinking unit rate for just one value. When we look for better buys, we're always looking at unit rates. For example, if we have a 21-ounce bottle of shampoo, that's $2.80. So if you take $2.80, which is a 21-ounce bottle, and we're going to compare it to a bottle that's $1.35, and that bottle has 12 ounces in it, finding better buys, one thing you can do is figure out, well, how much is just 1 ounce? So you can figure out, where you're getting more for your dollar. A lot of times we buy, families buy a lot of items at like a Sam's Club or a Costco because of the bulk. And we also though have to look and be realistic. Is it more for our dollar? Are we getting more in terms of, is it less per whatever we're working with? Like if you're looking at, toilet paper, and is the very large quantity at Costco cheaper than what you would see at at Target? And so you'd compare like how much for just one roll in a very large quantity versus a smaller quantity at Target to see what your better deal is. So here, if I want to figure out 1 ounce, so 21 divided by 21 is 1, so we divide by 21. 280 divided by that 21 would give you approximately 13 cents per ounce. And here, if we're looking at dividing by 12, $1.35 divided by 12 gives you about 11 cents per ounce. So that means the 12-ounce bottle is the better deal here because it's less per ounce. The cheaper one right here, 11 cents per ounce. Not by much, but in general, it does show us that we're getting more for our dollar. Can you say, oh, and I guess one quick thing here too is you can estimate too. If you know that you've got 12 ounces and you're thinking, okay, well, you could double that and see what doubling it would be. Doubling that would be $2.70 for a 24 ounce, and that's cheaper than the 21 ounce bottle. So you can look at it that way too, but all better buy problems can also be solved by figuring out how much is just one. So can you say I can write ratios and unit rates, and I can use rates to solve problems? Here's your output, and be prepared with any questions for the work time in class.